All right, section 11.6 is volumes of pyramids. So the volume of a pyramid is the volume is equal to 1/3 the base times the height. Again, the height is going to be right here. Okay, it's not going to be the slant height here. We'll talk about that one here and near the end, but we'll just need that for to find our height. But again, it's just 1/3 where again the B is the area of the base and H is the height. And the B and the one that they're showing you here, it's a rectangle, but it could also be it can be anything really. So it could be a triangle also. You'll see as we keep going along, we'll have some other ones there. So anyways, it's pretty much like what we did last last section. So example 1, find the volume of the pyramid. So again, we're just going to use our excuse me, I need to put some, we're just going to use our formula, which is 1/3 capital B, which is again is the area of the base, times the height. So we're going to take 1/3, and again our base here is 4 times 4, and our height is 2.4. Right? And if I plug all of that into my calculator, I simply get 12.8 meters. And again, remember, volume is always cubes, so it's going to be cubic meters. And we're done with that one. So again, it's going to be the same thing like we did last time. Like I said, we're going to find the volume, and then we're also going to have to find the side length or the height or something, based on what we have. For example 2, a square pyramid has a height of 12 centimeters and a volume of 64 cubic centimeters. Find the side length of the square base. So again, I'm going to use the formula V is equal to 1/3 capital B, which tells us it's the area of the base, times the height. On this one here, I can say that I have 64 is equal to 1/3. Again, the base, I don't know, but I know that the height is 12. So now you just have to decide, what do you want to get rid of first? Well, if I get rid of the 1/3, that means I'm going to multiply both sides by 3. If I multiply both sides by 3, that'll give me 192 is equal to 12 times B. Again, to get B by itself, I'm going to divide both sides by 12. And then that will give me that B is equal to 16. Now, if we know that B is 16, remember they're telling us it's a square, so I'm going to let X equal the side length of a base. So then we know that our capital B is going to be X times X, or X squared. So we know that X squared, from what we said earlier, is equal to 16. Again, remember the way we get rid of a square is we're going to square root it. And if the square root of 16 is equal to 4, and remember that's going to be a linear term, so it's going to be 4 centimeters, and we're done with that one. Example 3, find the height of the triangular pyramid. So again, we're just going to use our same formula that we've just been using. So it's going to be 1/3 the base, capital B, which is for the base on this one, times the height. So on this one here, now look at our base. Our base is a triangle. So remember, on this one here, our base here is our little base. So we can say it's 1/2 the little base times the height. So our little base is equal to 24 meters. And our height for this one right here is equal to 8. So if you work that out, you will get 96 meters squared. All right. So now we're going to still use our formula. So V is equal to 1/3. We have 96 there. right, times H. And what's our V there? Our V is actually what? 384. All right, so again, if I solve this one for H, again, why don't I multiply 3 on both sides? All right, or actually on this one here, it's actually easier and nicer if I take 96 divided by 3. 96 divided by 3 is going to give us 32. And that will equal 384. And divide both sides by 32. And that will give us H is equal to 12 meters. All right. And then lastly, again, we did composite solids on the last one. We're going to do composite solids here. So again, it's just up to you. Okay. I think your book calls it the top one, the volume of the top and the volume of the bottom. So I just like calling the top one V1, and I like calling the bottom one V2. So I know that my V total is going to be V1 plus V2. All right. So if we look at the top one here, I do not have the height. I need the height, which is right here. And remember, the height is going to make a right angle, and it's going to go here. All right. So if you look at what I did here, ladies and gentlemen, I actually made a triangle there, correct? So if we think about it, this one here is 10. And again, this one right here, since it's going to bisect it, that's going to take half of 12, which will be 6. All right. So if you remember from earlier, we had special right triangles. And again, if we think about it, this here is 2 times 3. This one here is 2 times 5. And then this one here, our H, which is what we're going to call that, would be 2 times 4. So our H is equal to 8. All right. Or you could use the Pythagorean theorem. Which will tell us our H squared plus 6 squared is equal to 10 squared. Or our H squared plus 36 is equal to 100. We're going to subtract 36, so I'll get H squared is equal to 64. If I take the square root of that, I'll get H is equal to 8. So notice, either way, I've got the same answer. Again, if you're used to seeing the special right triangles, it kind of makes it a lot easier than having to do the Pythagorean theorem. So anyways, so now that we have that, we can go ahead and take our volume 1, which would be 1/3 the base times the height. Well, the base is going to be 12 times 12. So we're going to have 1/3, 12 times 12, times our height, which we just figured out was 8. And if I work that out, ladies and gentlemen, I plug it in, I'll get 384. The volume so our V2, all right, would be again the area of the base, which is 12 times 12, times the height. And if you work that one out, you get 1,296. So what we just said, our total volume of our solid is going to be V sub 1 plus V sub 2, which is equal to 384 plus 1,296. If we work that out, we'll get 1,680. Again, we're talking about volume, so it's always going to be whatever it is, in this case, meters cubed. Okay? Stuff we've done before. It's pretty easy. Good luck.